Hello! In this video, we are going to prove the following theorem. No group is the union of two proper subgroups. So to start off the proof, let's consider a group G with identity element E. And from here, we want to show that G is not the union of two proper subgroups. And to see why, assume for a contradiction, we instead have that G is the union of two proper subgroups. I'll call them H1 and H2. Well then, the union of H1 and H2 is equal to G. And since H1 is a proper subgroup of G, this means that H1 doesn't contain all of G. So we must be able to find some element in G that does not belong to H1. I'll call that element A. And similarly, since H2 is a proper subgroup of G, this means we can find an element in G that does not belong to H2. I'll call that element B. Now, since A is an element of G, we have that A is an element of H1 or H2. But A is not an element of H1, so we must have that A is an element of H2. Similarly, since B is an element of G, we have that B is an element of H1 or H2. But B is not an element of H2, so we must have that B is an element of H1. Now, since H2 is a subgroup of G, the inverse that A has in H2 is the same inverse that A has in G. So we can say that the inverse of A belongs to H2. And similarly, since H1 is a subgroup of G, we have that the inverse of B belongs to H1. Now, since A and B are elements of G, it follows that A times B is an element of G. So A times B is an element of H1 or H2. And we're going to show, in either case, we reach a contradiction. Let's start with the case that AB is an element of H1. Now, if AB is an element of H1, well, we also know that the inverse of B is an element of H1. Since H1 is a subgroup of G, we know that H1 is closed under the operation of G. So AB times the inverse of B is also an element of H1. But we can simplify this down to A. Because, applying the associative law, we can move the parentheses around B times B inverse. And then B times B inverse is the identity element, and A times the identity is A. So, since this guy is equal to A, that tells us A is an element of H1. But this contradicts the fact that A is not an element of H1. So this completes the case that AB is an element of H1. Now let's consider the case that AB is an element of H2. Well, in this case, since AB is an element of H2 and the inverse of A is an element of H2, that tells us the inverse of A times AB is an element of H2. But we can simplify this down to B. Because, first applying the associative law, we can move the parentheses around A inverse A. A inverse A is equal to the identity element, and the identity times B is equal to B. So, since this guy is equal to B, this tells us B is an element of H2. But this contradicts the fact that B is not an element of H2. So, in either case, we reach a contradiction. Our assumption that G is the union of two proper subgroups led us to a contradiction, so we must instead have that G is not the union of two proper subgroups. And so this completes the proof. And so yeah, that's pretty much it for this video.